Hello everyone and welcome back. So this time we're going to do an example. Now, as always, I'm going to pause somewhere in the middle and let you try it on your own. So make sure you try this before you just go and see the solution. So let's look at the problem. So first off, we see we have a box. It weighs 550 pounds. Pounds is a force, so we don't need to convert anything. We have two cables holding up, cable AC and cable AB, or ropes AC and rope AB. For one of them, we're given an angle. That one we're giving a force triangle right here, a little slope triangle, force triangle, whatever you want to call it. Now, how are we going to solve this? Well, you need to draw a free body diagram for point A and apply the equation of equilibrium. Things to remember, these force slope triangles are super easy because remember that cosine of some angle, like if we have 3, 4, 5, well, if this is theta right here, then cosine of theta is equal to adjacent, which is 4, over hypotenuse. I don't even have to know that angle. I just know that it's 4/5. So any place I would use cosine of theta, I put 4/5. So don't forget that. Okay, that in mind, I'm pausing for just a second. Go ahead and try it on your own now and see how it goes. Okay, so 3, 2, 1. Hopefully you've tried it on your own. And now let's go on to the next slide. So first off, a free body diagram. We cut everything. We draw a little circle here. We get rid of everything outside of it. And we replace it with these forces. We know what the force going down is. That's 550 pounds. We don't know either one of these forces, so we need to solve for them. But hey, that's only two unknowns, and we've got two equations we should be able to solve. Other things to think about that are unknowns are directions. You need to have either a direction like this, some sort of position coordinates, or a slope triangle in order to be able to really solve these problems. If you don't see one of those things and it's not directed along one of the paths, then you're going to be in trouble. Now we need to break everything up into components. That's too quick. They're just doing right at the end. So we're going to break everything up into components. First off, let's do force C. So we have force CY and force CX. And we know what the slope is. We'll get to that later. We have force C. So if I was doing it normally, I would say, well, this is theta, so this is sine of theta right here for force CY, and it's going to be cosine of theta for force CX. So FCX would be equal to force C times cosine of theta. In this case, though, we know our slope triangle, so I can replace that cosine of theta with 4/5. That's pretty nice. And similarly, for force CY, I would get force C sine of theta. I already know what my slope triangle is, though, so I should just force C times 3/5. It works out pretty nicely. Okay, let's erase this right here. And we would do something very similar for our force B. Be very careful with your sign, though, because force C and force B, they're pointing up, but they're also pointing in to the left and the right, respectively. Actually, opposite respectively. So force B, we draw it going this direction. We see that our force BX will be negative. We have our force BY right here. Force BX right here. And we have 30 degrees. So once again, we can solve. So we know that force BX is going to be equal to force B times cosine of 30, because it's the adjacent side. And force BY is going to be equal to force B sine of 30, because it's the opposite side. Adjacent over hypotenuse and opposite over hypotenuse. Don't forget the whole SOHCAHTOA then. Now if we plug these in, we can solve for force B and force C. We get that it's 478 pounds and 518 pounds. Just be very careful that you don't forget your minus signs here. The weight is negative because it's pointing down, and the x component of force B is negative because it's pointing to the left. You could say that the right is negative if you wanted to, but you have to make sure that you're consistent throughout your entire problem. So with that, we have solved, and we're good to go. As a note, if you had forgotten to make one of these negative or positive, you may have still gotten the right number, just with the wrong sign. Just always remember that for ropes, if you pick a point, it's always going to be pointing away from that point. So if you get a negative number, it's telling you that it's supposed to be pointing towards that point, and that can't happen, so you made a mistake. So if you ever get a force that's a rope pushing on something, you have made a mistake. Do not forget that. So this, we finished example 1, and next time we'll try another little bit example for this, and keep on going, okay? Hope this helped you, and I'll see all of you next time. Bye-bye.